Welcome to the inaugural post, video, or podcast of my new space, which I hope to keep fresh with insightful and interesting new content. I chose to narrate my blog posts either in video form or in audio form, so that if you prefer a different medium from reading, you can listen to me reading them to you if that's what you prefer. If you want to read them with your own voice in your head, then please, by all means, feel free to visit my blog and read them for yourself. But if you're busy, if you're in a hurry, if you rather do something else while you listen to this content, please join me in the next couple of episodes. So today I'm gonna talk about principles of developer experience in 20 minutes or less. And as a front-end engineer and engineering manager, I focused on building developer tools for open source projects such as Jest, React Native, or Metro for the past 10 years. And I'm restless in searching for a better user experience. I lose sleep over misaligned pixels. I deeply care about how people feel about the tools that they're using every day. This experience informed how I think about building software, and the team that I work with lives by several principles that we define together. I'm sharing this manifest with you in hopes that it'll be useful to shape your high-level thinking of developer tooling too. Developer experience, or DevX, is the experience that developers have when building, maintaining, testing, deploying, and analyzing software. Think about all the tooling that you use. Some of them are probably hard to use, slow, and there aren't any plans to improve them. And usually, it's not something that organizations get to spend a lot of time on. Developer experience gets prioritized, and arguments for investments can be quickly shut down because there's no direct connection between improving developer experience and generating business value. This disconnect makes it hard to measure the impact of focusing on DevX. It also means that developers must ruthlessly prioritize any DevX work. How can they bring value to developers in the minimal amount of time? Let's start by completely reframing how we look at tooling. Developer tools are products. Internal tooling is rarely intuitive, documented, or fast. If we want to improve our tools, we must change our perspective and look deeper at developer tools as real products. Products should be well defined, have carefully crafted workflows, and focus on achieving satisfactory outcomes quickly. The best products are delightful. Let's think of developer tooling as a means to increase the velocity at which engineers deliver solutions. We can define metrics that can substantially impact user satisfaction or developer velocity. For example, if we suppose common repetitive tasks can be completed 10 times faster or more efficiently, developers will ship projects sooner, end up switching context less often, and likely be happier. Productivity is hard to measure, and we'll approximate metrics in a future post. For now, we'll focus on building a framework for thinking about developer experience. The developer experience principle stack. I'm going to list principles in order of priority, and the first principle is the lowest in the stack, meaning it's the foundation that we are least likely to violate. And the stack is necessary because when we have to make trade-offs on principles, we'll always choose to stick with the ones lower in the stack. Imagine a stack of books. It's easy to take off a book on the top, but removing a book on the bottom requires a lot of effort. And every time you do, you end up with a different order of your stack. You may even get rid of some books in your stack. It's kind of, shaking you. And you'll only want to touch the book on the bottom when it's absolutely necessary. So we'll go through 5 principles today. Focus on the user, we'll never violate this, that's on the bottom of our stack. Incremental migration, clarity, reevaluate assumptions, and maximize option value. The last one on top, we might have to violate that one. If that's on top of our stack, we might be okay with that. It still might hurt a little bit. The great thing about principles is that once we define them, decisions become obvious because everything turns into a matter of trade-offs with clear resolution paths. However, as we'll see below, it's painful when we do have to violate the principle. That's the entire point of principles though. The most essential principle is to always put the user first. For developer tooling, that means first, the workflow performance. How fast does it execute everyday tasks? 2, signal. How actionable is the tool's signal to support the developer in achieving their goal? 3, reliability. How reliable is the tool in completing a task? 4, user satisfaction. How do users feel when they use the tool? 5, documentation. How clear is it for a user to get started? And can they effectively unblock themselves when they're stuck? 6, accessibility. Can everyone use the tool and understand its output? 7, scalability. Does the tool scale for the growth of the organization and the code base? Two angles to this often make it challenging to focus on this principle. One, focus on tomorrow's user. It's essential to focus not just on today's user, but to make systems scalable and maintainable for future users and the growth of a code base, product, or organization. Even though we may focus on user value today, it may make more sense to prioritize the value the tool that will bring to tomorrow's user. Deprioritizing immediate work is in direct conflict with providing value to users quickly, but it will bring more value to users over a longer period of time. And the second one is to do the boring work. Some developers will go to extreme lengths to justify going after fun and shiny projects. This list of priorities can serve as a countermeasure. An explicit user focus will almost always shut down grand ideas about complete technology rewrites in favor of the monotonous work. Here are two concrete examples of a user focus on something called error signals. For example, on Jest, the primary goal of a testing framework such as Jest is to ensure correctness. The secondary goal is to provide highly actionable signals immediately when something goes wrong, when a test is broken, for example. That's why hundreds of hours of free and paid open source work went into designing Jest error output and intelligent scheduling to give actionable feedback to developers quickly. Another example is that Rick Hanlon on React Native completely redesigned how errors are displayed on a device when something goes wrong. This change improved user actionable feedback and speeds up how quickly users can resolve programming mistakes. The second principle we'll talk about today is incremental migration. Most tech stacks grow out of necessity, not through careful planning. And that's a good thing. If all your business focuses on is your tool's folder structure, you're unlikely to be successful, unless, of course, your business is folder structure as a service. As organizations scale, more and more infrastructure tightly connects with other systems and becomes harder to change. It'll usually take far longer to rewrite most existing systems from scratch than it would take to migrate them incrementally. While it might be great to consider the ideal solution to all problems if we could start from scratch, the cost of change or the sunk cost is often so high that it's simply not worth considering a full rewrite. Instead, I generally recommend creating incremental value. Done is better than perfect, and a few rough edges are acceptable if there's a viable path forward to a system that's close to ideal. I learned this principle through the incremental rewrite of Jest that started in 2015. Jest came with a few good ideas, but nobody was working on any improvements. At the same time, Facebook heavily depended on it for various projects. It wasn't feasible to build an entirely new test framework and migrate tens of thousands of existing tests to it. Instead, I chose to separate concerns and rewrite individual pieces in place. Incremental migration is the perfect principle to highlight what will happen when we violate it and why we might choose to do that. Let's say we exhausted all other options and we concluded our system won't keep scaling for the codebase and organization's growth. We have to go for the daunting rewrite. We'll start from scratch to do a long-term rewrite with a high chance of failure while pausing maintenance on the existing system. And that's painful. The point of priorities is not to always stick with them, but rather to be aware of which trade-offs we're making when we do violate them. But beware, I was involved with multiple projects that ultimately failed to achieve their goals. Like a rewrite of our package manager changed so many constraints it wasn't applicable anymore. And two, our JavaScript compilation pipeline rewrite took longer than expected, ended up being too complicated, used the wrong toolchain, and eventually failed as people lost interest. So to make sure we're forming the right opinions, we need to fully understand the system, bringing us to the next principle, clarity. The third principle, clarity, is important because I mentioned before that it's hard to justify work on developer experience. We have to focus on clarity, beginning with the plans, the narrative, and the definition of metrics or goals. We can apply clarity from the project management level down to the separation of concerns, APIs, and maybe even variable names. Focus on the essential words to describe complex topics. Not only will that help the narrative of your plans or help people better understand the proposed work, it almost always ends up with less complicated infrastructure too. I learned this the hard way. I once had what I thought was a fantastic proposal to improve JavaScript infrastructure at Facebook, but I got feedback that it didn't add up too much and it was hard to understand, and people were like, "Christoph, what are you doing?" And I thought, it's all right there in the document. What's so hard to understand? But upon reflection, I realized that I had a lot of good raw ideas and project plans, but I had no overarching narrative that clearly explained the plan's purpose. I switched everything around and broke down my proposal into multiple phases. The first one was fully specified, focused on a single critical workflow that every developer would use for hours every day. And once I turned around the project plan, I got buy-in from everyone. And I discovered few more concrete ways to reduce the system's complexity by looking at it from a different perspective. And this experience taught me that it's never too early to share a draft. Nowadays, I test high-level ideas or specific code changes I'm planning with people who have the most context. That could be people who worked on this infrastructure in the past, people I trust to give honest feedback, or really anyone that's willing to listen and bounce ideas back and forth. It frequently helps me understand downstream effects that I wasn't aware of previously. Clarity ended up in my principle stack because I used to make the mistake that tools should get out of the way and be invisible. Now I'm convinced that was misguided. I was masking complexity in the name of simplicity instead of surfacing the right level of complexity at the best interaction point with the user, which also directly led me to discover another principle. Continue to reevaluate assumptions, constraints, and trade-offs. Diving into an existing system often yields variants of harsh statements like, wow, this is the worst design I've ever seen. Who would ever write such complex code for such a simple problem? And then often followed by the sudden realization that this person was, the original author of that piece of code, and then quickly taking back all the mean words. Assumptions, constraints, and trade-offs tend to change over years or even just in a few months. It's even worse to be aware of that and not to do anything about it. At the same time, it's essential to recognize that what was built in the past probably wasn't bad, just that at the time the constraints or the assumptions were different. Gaining context on the past will help make better decisions and more extensive changes to existing systems in the future. Be honest about trade-offs because most technical solutions will have negative trade-offs. Don't pick solutions that will put you or your organization in a worse position in the future. Secondly, aim to make things easier instead of building complex abstractions on top of complex systems. For example, in the past, I used to believe that all JavaScript tooling should be built using JavaScript because that's most familiar to JavaScript developers, right? That way they can change and improve tools as they like. However, it turns out that there aren't that many product developers that go and make changes to JavaScript infrastructure, and we have been making the trade-off to spend a large amount of time building more and more complex solutions to keep tooling fast. Maybe it's time to start building better tool chains using other languages with better performance guarantees. If we go for this, we can hold on to the above principles and try rebuilding an isolated part of our system to stick with the incremental migration principle. There are also downsides, and there are going to be trade-offs as well. This brings us to the final principle, maximize option value. The final principle is about retaining or gaining option value, which means any change to a system should unlock more options for improvements and significant future changes. If we zoom out, these principles exist because we often get into a state with developer tooling that makes it hard to introduce major changes that are gradual. After all, there is usually little option value embedded in the design of existing systems. If we keep option value in mind when redesigning infrastructure, we can naturally adapt to new requirements in the future. For example, monolithic toolchains cannot move fast as they often don't have clear API boundaries. In such a case, we gain leverage over all parts of our infrastructure by modularizing it. Once we have a clear separation of concerns, we can have competing implementations of the same pieces that are well defined in scope and can be swapped out with better versions as needed. Another example is reducing external dependencies or choosing them more carefully. Yeah, third-party dependencies undoubtedly help us move fast initially, but using them means we lose control over our stack. We gain option value and control by removing dependencies or by actively maintaining them through taking ownership of those dependencies. At Facebook, taking ownership of external JavaScript dependencies allowed us to reduce our third-party dependency install times by 10x. We removed, upgraded, and replaced many dependencies over the course of a few months. It was boring work, but everyone now saves dozens of minutes per day, and we save days of CI time every week. Other contenders for principles. The list of principles could be endless. I generally find the sweet spot to be around 5 principles for any domain, each having a few sub-principles. If there are more, they tend to become hard to remember. And we'll see that in a future post where I list priorities, and there are more, and it's hard to remember them. And it is overwhelming to apply so many principles to decisions consistently. There are many other contenders for DevX principles, and you may choose other principles in your organization or your projects. Some of them could be scale. Some organizations or tools may want to define an explicit principle on enabling various levels of scalability. Growth. In some places, especially early in startups that build developer tools, optimizing for user growth may be the primary principle that has a downstream influence on every decision. And then complexity or simplicity. While clarity is good enough for me to touch on both complexity and simplicity, you may want a more well-defined principle on the complexity you'd like to avoid or the simplicity that is core to your product. Principles in the wild. I shared high-level principles for how I think about the developer experience space in general. Individual tools can apply these principles to identify their tool-specific principles. If you're the maintainer of a popular and well-scoped tool, you should absolutely define your principles, write them down, and share them with your users. Ideally, your principles won't change much over the years, and if they do, that might mean your project is changing substantially too. Here are 3 of my favorites. Figma's engineering values, principles for operating a team focused on design tools. React's design principles that were initially shared in 2016 and upheld through every significant change. They outlined half a decade or more worth of work, and it established how the team works. The fish shell principles. Fish shell is an absolutely delightful product. It's easy to make a direct connection from using fish shell back to their principles. If you squint, you'll find that many of the principles that I described also apply to other domains. In a follow-up post, video, or podcast, we'll explore how to measure developer experience. And that's it. That's the first post, the first video, the first podcast of my new space. Please tweet about this article, share it with your friends, discuss it with the community. There's a link on the post, or email me. I'm happy to receive feedback. I haven't been doing this in a long time, so I'd love to get better at writing, at recording videos, at doing podcasts, at all of these things. So thank you for reading and have a great day.